So as we mentioned in the last lesson, our calculator has a bit of a logical issue. It lets us add as many decimal points as we want. And this will dramatically screw up our app because when we try to, say, multiply this by -1, or when we try to turn it into a percentage, we have a fatal error. And the error is, of course, cannot convert display label text to a double, because I'm not even sure what 2.3.6.23 is as a number. It's definitely not a decimal number. All right, so what can we do instead? Well, down here where we've got our num button pressed, we should be able to check to see if we currently have an integer in here. So say if I had an 8 in here, then I should be able to use the dot button. But if I already have a double, say 8.5, then I shouldn't be able to press this button or add that dot to the display anymore. So in order to do that, we're going to tap into the else statement inside the num button pressed. Because when isFinishedTypingNumber is true, then the current value in here will be 0. It's only when we've got an actual number in here and we've switched isFinishedTypingNumber to false, where we actually want to check if the current number value that's being typed in is equal to a full stop, namely a decimal point. And in that case, then we can say that let isInt, so we're going to create a new local constant equal to floor. So we're going to round down whatever is currently inside the display label. So it's expecting a double, so I have to convert our display label to a double. Then I'm going to say display label dot text. And now I've got whatever it is that's currently inside my display label rounded down to the floor. So say if I had 8.1 in here, then it would round it down to 8. So now I want to be able to compare this with the non-rounded down version of my display label dot text. Now, just as we saw previously, I can either force unwrap the double initialization to say that this will always be convertible to a double, or what I want you to do is to write a guard statement that checks whether if this is in fact convertible to a double, and also to add a fatal error and a message if it is not. So same as what we did before, pause the video and see if you can complete this challenge. All right, so this is not so hard. We're just going to write a guard let, and we're going to say current display value equal to the display label dot text cast into a double. Now, if this is not true, i.e. it fails, and we get a nil, then we want to throw a fatal error where we say cannot convert display label text to a double. And now, instead of using this number, we can simply use the current display value over there and over here. So now our code looks a little bit simpler. And all it does is it says round down the current display value. So if it's 8.1, round it down to 8. And that's what the floor method does. It simply rounds our number down. Now, the other part is comparing whether if the rounded down version of our display value is equal to the current display value. So is 8.0 equal to 8.1? Well, that's false, right? So then is integer becomes false. Now, however, if I had 8 in here instead, then 8 rounded down is equal to 8. So isInt is equal to true. And so this means that we can check to see if we don't have an integer, namely we've got a number that has a decimal place in here, then isInt is false. So if isInt is a false, then we're simply going to return. And this keyword forces our function to return, and it means that we don't continue appending the current num value, which remember is a full stop, to the display. So let's go ahead and run this and see what happens. So let's try 8.1, and then I'm going to try and add another decimal place to the end of this. And you can see that no matter how hard I press, it's not letting me. But if I clear the screen and it was a single integer number, then I can add a single decimal place. So that's sorted out our little problem there.